Hello, Nick Leifker here, and welcome again to Management 409, Operations Management. I just wanted to go over the steps again, one by one, to make sure that it's understood what happens step by step with regard to PERT CPM with uncertainty, because there are a lot of steps involved here. And because of that, well, it's good to have all of those taken care of, all of those straightened out. Now, it's important to note that, well, much of this can be calculated using Excel. In fact, that is part of your project, to calculate most of this using Excel. That said, it's still a good idea to walk through the steps so that you understand what's going on. So, for instance, the first thing you have to do is you have to calculate the mean completion time for each task. You take the minimum, expected, maximum times for each task, and you calculate the mean completion time for each task. And that's just going to be minimum plus 4 times expected plus maximum, all divided by 6. Now, again, some people calculate task variances at the same time, and if you're using Excel, you probably will, and then use some other function to determine which variances you'll use and which ones you won't. So that formula is maximum minus minimum, that squared, all divided by 36. So again, you start by calculating the mean completion time for each task. So once that's done, you take those mean task times, and that becomes the task completion time. And you'll use that within your good old PERT CPM framework. So you'll draw out the project flow map. You'll go forward through the project to calculate earliest starts and finish times for each task. Once you have that, you should have the mean project completion time. And then you'll go backward through the project to calculate latest finish and latest start times for each task. And once you have latest finish and latest start, you should be able to calculate the slack and the critical path. Now, it's important to note that steps 1 through 3 here, this is your standard plain old PERT CPM. This is ordinary PERT CPM. It's just that you have this framework around it to handle the possibility of variation, the possibility of uncertainty. So, once you've determined the critical path, well, this time, if you haven't already, you calculate the variances of each task on the critical path. So, once you have that, once you have the task variances for the tasks on the critical path, you add those up, you sum those up to get the variance of the project completion time. And then, once you have that variance, you take the square root of the variance to get the standard deviation of the project completion time. Again, once you have the standard deviation project completion time, you have a mean and standard deviation. You have your normal curve. And as mentioned, you can do a lot of things with a normal curve. So, once you have that normal curve, well, you can find the probability of completing a project by a deadline. In other words, find where a particular point is on that normal curve. So to find the probability of completing a project by a deadline, you find the z-value for that deadline. So you calculate the z-value. It's just the deadline minus the mean, that difference, all divided by the standard deviation. The deadline will be given to you. The mean is just the mean completion time of the project that you calculated back using PERT CPM. The standard deviation, well, the standard deviation is the project standard deviation that you just calculated. Then, once you have that z-value, you convert that z-value to a probability using the standard normal table. And then, well, if you're using Excel, you can use the norms dist function. You put in that z-value into your norms dist function, and that gives you the probability. The probability that you'll finish the project by a particular deadline. So that's the steps involved with regard to PERT CPM with uncertainty. The first thing, you find the completion time, the mean completion time for each task. Use that mean completion time for each task in good old PERT CPM to find the project completion time and the critical path. Then you use the variance of the tasks on the critical path to find the standard deviation of the project completion time. Then, once you have a mean standard deviation of the project completion time and a deadline, you can then find the probability that you will complete the project by that deadline.